What's up guys, my name is Shiv and today we are going to study or discuss about sound. So first of all, sound. What is sound? What is sound? Sound is a source. Sound is a form of energy that stimulates our sense of hearing. So I will write here a definition that sound is a form of energy. Sound is a energy or form of energy that stimulates our sense of hearing. Our sense of hearing. So this is a definition of sound. This is a definition of sound. So do you know that how sound is produced? So sound is produced by vibrating an object. If I am speaking, then my tongue is vibrating, but it is in very small scale. You can't see that, but my tongue is now vibrating if I am speaking. So sound is produced by vibrating an object. Vibrating an object. Sound is produced by vibrating an object. So now what is propagation of sound? Propagation of sound. So what is propagation of sound? Propagation of sound means that sound can travel in all direction. Sound can travel in all direction. You have noticed that if a music is playing your neighbor's house, it reaches to you, but it not in straight line. Means you can hear at your means 5 meter also. If you are go uh, if you go far, then you can hear that also. If you change your position, you can hear that music. But why? So answer is because sound can travel in all direction, not as a light. Light travels in only one direction. If I light torch or a bulb, then light is given only in specific room, specific area. But sound travels in all direction. It spreads out. It spreads out. Now we will see that uh, longitudinal waves. Longitudinal waves. So what is longitudinal waves? And it is very important point. That sound is travel. Sound travels in only sound wave. Sound travels in sound wave. So suppose this is a sound wave. We will study about sound wave later in this video. So first of all, longitudinal waves and longitudinal wave. What is longitudinal wave? So longitudinal wave has two parts. First is compression, and second is rarefaction. Rarefaction. So what is compression first? So compression means that area in that sound waves are very compressed, very closer together. Suppose this is a room. So first one sound wave here, one here, one. They are very compressed, very mixed up. And what is rarefaction? So rarefaction is a that area that sound waves are very far in a distance. Suppose this is a room, then one sound wave is here, one is here. So like this is rarefaction. So we can write this also compression. Compression. This is the definition of compression. Compression is that area. In that sound wave are very compressed or very compressed. And rarefaction is that area in that sound waves are very closer. So this is the definition of compression and rarefaction. So hope you understand this very simple concept. Now we will study the oscillation or a deeper in a sound wave. So I have I told you that we will study sound wave. So first, as I mentioned, first of all is oscillation. Oscillation. So what is oscillation? Oscillation is a to and fro motion of sound. Suppose this is a sound wave. The to and fro means to and fro means um, up and down, up and down, up and down. So you can see the sound wave is going up here, then coming down, up, down, up, down. So this is called to and fro motion. To and fro motion. In physics, we have learned that repetitive motion means it is repeating the same motion. That is also to and fro motion. So oscillation is a to and fro motion of a sound wave. Motion of a sound wave. So this is a oscillation. So now frequency. What is frequency? So frequency is a oscillation completed in 1 second. Means uh, suppose this sound wave take one oscillation. Sound wave take 50 oscillation to complete in 1 second. Means in 1 second this wave is completing 50 oscillation. That means the frequency will be 50. So now time period. Time period. So what is time period? Time period is a all means suppose sound wave travels here to 5 meter of distance. Sound wave travels 5 meter of distance, and means time period means all the oscillation completed by sound wave is called time period, is measured in time period. So don't get confused in frequency and time period. Frequency is only 1 second, how many oscillation completed in 1 second, and time period is the whole time the sound wave completed, means whole time the sound wave completed the oscillation. Now wavelength. So what is wavelength? We will write here wavelength. Wave, wavelength. What is wavelength? Wavelength, you can see here, suppose here is a sound wave, then the up, you can see the distance between two sound waves. Suppose this is a one sound wave and this is second. The distance between two sound wave, is called wavelength. So there are two waves here, and the length between them is called wavelength. So this is the basic of sound wave. You have here that frequency frequency is 50, 60, or you have heard that hertz. Hertz. So what is hertz? Hertz means frequency is count in hertz. Frequency is count in hertz, and time period is count in one by time completed. One by time completed. So this is a time periods measuring, and this is hertz is a frequency measured in. So now we will see that sound wave parts. So suppose this is a sound wave. Now I have mentioned before this distance between them is wavelength. The to and fro motion is oscillation, and the very upper part of a sound wave is called crest. Very upper part of a sound wave is called crest. Here also very upper part is crest. Now the lower part means bottom part of a sound wave is called tuft. Tuft. So this is a crest and tuft. Now we will study the what is loudness. What is loudness? So loudness means depends. You can say depends on frequency. So loudness depends on only frequency. Loudness depends only on frequency. If I say loud, very loud, then the sound wave coming through my mouth is very high, very high. So the loudness is measured in frequency, and frequency is measured in hertz, as I mentioned before. So now we'll study absorption of sound. So there are many objects that absorb all the sound. So examples like carpet. Carpet absorb all the sound. Uh, if you see that play a music in a room and keep it in a table on a table, then it is much louder. As if you keep that phone in, or you can say on the carpet, the sound is coming very low. That's because the carpet absorb the sound. Now second example is curtains. Curtains also example of absorption of sound. Then there are gunny bags, and plywood also absorb all the sound. And the most absorbing object that absorb all the sound is foam. Foam absorb all the sound. If you say that, if you hear also that that man has made a soundproof room, it means in that room there is a field of foam. There is very foam, so that if we play music, that foam absorb all the sound, and sound cannot travel or cannot go through the outer the room. So we will call that soundproof room. So this is all about sound wave. We have studied all about, and one thing is remaining, that it is a fun fact. I will say fun fact that the bats, Chamkadar bats, uh, do not see. They absorb the sound. They absorb the sound to sense what is next to them. Means they throw the sound wave and it returns to their ear, and they sense what is next to them. They can't see. So this is a fun fact about bats. So now we have completed our sound chapter. So if you love this video, then like and subscribe our channel and leave a nicely comment below.